Today we're going to talk about taxicab geometry. We will define what we mean by that. We will give some very simple examples, and we're going to see how circles look like in this geometry. And after that, we're going to compute pi in a separate video. Okay? First, let's introduce some coordinate system. Okay, let's base our coordinates on O that has 0, 0. So O has 0, 0. Let me make it bigger, 0. And let's call this one the x-axis, and this is the y-axis, okay? And for the measure of distances in Euclidean geometry, we used the following. If we are given 2 points, let's have this one A, and we assume that it has coordinates x1, y1, and this point B that has coordinates x2, y2. So to compute this distance between A and B, we are used to think of this one as a triangle and computing this distance as a C using the square root. Okay, here we are applying the Euclidean geometry, but basically we are using the Pythagorean theorem. Okay, so the distance between A and B, these subpoints A and B, is given by let's say the distance between A and B is the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, so this is my distance C. For us, the taxicab geometry is going to be done in different manner. So to go from point A to point B, we just go horizontally or vertically. Okay, here we see that we can go from A to B. We go to this point here. So we're going to take this distance, and after that we take this one here. So we think of it as a taxi. Okay, if we take a taxi in a city, okay, so you go from point A to B, you go to this point, let's call it D, and after that from D you go to B. There is another way that you can go to point B. You can go to this point here, E, okay, and after that from E you go to B. Think of it as a taxi, okay? So that's why you call it a taxicab geometry, okay? And therefore the distances are computed as, so this is the absolute value of the y's difference, and this is the absolute value of the x differences, okay? So here, so this is x1 minus, so let's say x1 minus y1 minus y3, and this is x1 minus x2. And therefore we have the distance between points A and B, or any other points, is given by, let's say point A has coordinates x1, y1, and point B has coordinates x2, y2. So the distance between A and B is going to be the absolute value, x1 minus x2, or x2 minus x1, doesn't matter because of the absolute value, plus y1 minus y2. Okay, so here this x1 minus x2 is this distance here. So this is x1 minus x2. And y1 minus y2 is this one here. So to go from A, point A to B, we drive from A to D, and after that from D to B. Or we can go from A to E and from E to B. Okay? So this gives us a distance, okay? We are not gonna define or prove the requirement for D here to be a distance, but we will see that in later when we need it. But to measure the distance between A and B, we go up and after that left, or we go left and after that up. Okay, I think you see what we mean. Now to use this one and see that it's a bit different from Euclidean geometry, we will use this distance to compute pi and to draw the circles in this new geometry. Okay, before we close this video, remember that a circle that's centered at A, B, and having radius r is computed using this one here. So for us, a distance from A and B that's equal to r means that x1 minus x2 squared plus y1 minus y2 squared is r squared. Okay, if we fix x2, y2, okay, so if we fix x2, y2 as AB, okay, and we let x and y change, we're going to have x minus a squared plus y minus b squared is r squared. And this is the general form of a circle centered at point A, B, and having radius r. We will see how we can draw circles in Taxicab geometry. And after that, we're going to compute pi. What's the value of pi in Taxicab geometry? Thank you very much.